Welcome to monochemistry. Today we're going to talk about reaction mechanisms as part of our kinetics unit. Reaction mechanisms are theoretical steps that allow the reactants to turn into the products. This reaction mechanism must be backed up by experimental evidence and must also show the rate law. Okay? And so it's interesting in chemistry. We have these equations like this, which shows a reaction between carbon monoxide and nitrogen dioxide. Looks pretty simple. Looks pretty straightforward. Nothing wrong with it. So why should we care about reaction mechanisms? Watch this. You do a little experiment in your lab to test the rate of this reaction, and bam! And you're all up in your lab like, what? I just can't even right now. Because you would have thought that the reaction would have been dependent on both the concentration of carbon monoxide and nitrogen dioxide. But your experimental data shows you that carbon monoxide has no role in the rate. What? Mind blown. This is where reaction mechanisms come into play. Let's continue by talking about the steps that make up reaction mechanisms. Reaction mechanisms are made up of two or more elementary steps. An elementary step is a simple reaction that represents a part of the progress of the overall reaction, but at the molecular level. Let me show you. So this is a reaction mechanism consisting of two elementary steps. Note that they are both bimolecular. And what that means is that you have two reactants colliding to form products. There's also such a thing as unimolecular, which means there's only one reactant, and it's not colliding with anything so much as interacting with itself and changing shape. There's also termolecular, which means that there are three molecules colliding with one another to form products rather. Now, termolecular reactions are very rare. Based on what you know about the collision theory and also about the kinetic molecular theory of atoms, explain to me and bring this answer to class why termolecular reactions are actually very rare. So those are elementary steps. There's two in this case, number 1 and number 2. One of them is said to be the rate determining step. Notice this one is slow and this one is fast. The slower of the two is the rate determining step. I want you to imagine that you're in a race, but instead of you racing against everybody else, you're on a team. You're on a team with 3 other people from the class. All 4 of you start at the same time, and the time it takes you to run the race only stops when the last person on your team crosses the finish line. So in that particular scenario, it doesn't matter how fast you are. Let's say you could be the fastest person on the planet. You could be the Flash. You finish that race in 0.2 seconds. It's 100 kilometers, and you finish it in 0.2 seconds. It doesn't matter. It only matters how slow the slowest person on your team is. So we have the slowest person on your team takes 100 minutes and you take 0.2 seconds. What's your overall time? Well, your overall time is 100 minutes because it didn't matter that you finished the race in 0.2 seconds because everybody needs to cross the finish line at the same time. Therefore, when it comes to reaction rates, only, and this is very important, only the slowest or the rate determining step determines the rate of the reaction. So if this is our rate determining step, it makes more sense now as to why our overall rate expression is written as follows. Note, and this is different from overall reactions, note that in an elementary step, the coefficient signifies the exponent in the rate equation. That's only for elementary steps. That does not repeat, not apply to the overall reaction like in previous questions that we've been working on. I'm going to erase some of this stuff now. There we go. Oh, not that one. Come back. There. Bring this guy back too. Okay, so there's one other thing I want to point out about this. And that is the fact that there are other pieces to these mechanisms. Besides the molecules that are reacting and forming, there are other pieces. Okay? Oops. Okay, so this reaction mechanism is as follows. Note that the overall reaction is the one that we wrote on the first page, and I'll show you how that works. Okay, so I'm going to pick a color here. Let's use red. Notice that on this side of the equation I have an NO3. So those are going to cancel out because I also have one on this side of the equation. If I have two elementary steps and I add the reactions together, my overall reaction is what I get when I add those two things together. And things that are on opposite sides of the equation are going to cancel out. Okay? Also note that I have an NO2 on this side, and I have a 2NO2 on that side. So note that the overall reaction is as follows. NO2 plus CO yields NO plus CO2. I just took what was left. That plus that yields that plus that. So the elementary steps have to do two things. First of all, they have to prove the rate law. Second of all, which this one did, second of all, they have to show the overall reaction, which it does. And if those two things fit together and work, then we can say that this is the actual mechanism, or it's a possible mechanism for this reaction. One other thing, this guy here that got canceled out, see how he was formed in one step and then used up in another? That makes this, NO3, is what's known as an intermediate. Okay? Now, one other thing that you have to be able to identify in these reactions is a catalyst. A catalyst will start at the beginning of one elementary step and then be reformed in another. So if something starts here and finishes here and still cancels out, doesn't show up as part of your original equation, that's a catalyst. Okay, so an intermediate is something that gets formed in one step and then used up in a later step. A catalyst is something that gets used up in one step and reformed in a later step. Both of those things will not show up in your overall reaction. Hey, and that in a nutshell is a reaction mechanism and how to use it to figure other things out about a particular reaction. Bring your questions to class.